Thanks everyone for showing up. It's the last day. We've all had a big week and lunch and maybe a few too many last night. So thank you for coming to our house instead of going home early or having a long lunch, which we'd like to do. I'm Lisa Davies. This is Brandon Coates and Chris Holt. We're from Oath. We're going to talk a bit about scale today, and we're really fortunate. These guys flew in late last night, so we have to thank them. They've both come from other conferences. One was an international flight. They're probably a bit jet lagged, so super helpful of them to make the trip for us today. What we're going to talk about is we're going to cover different architectures. As your Jamf environment grows, your needs will probably change, and how you can extend your architecture to take care of what your business needs. These two are going to talk about some of the security considerations that exist generally in the industry, and also with your Jamf architecture, some best practices that you can do, real-world problems, and maybe some of the attack vectors that are there, and some good hygiene with your security. So I'm going to start with the architectures. We all start out with that single server. We've just had our jump start. It's probably completely overwhelming. Probably not the people in this room, but maybe someone watching it later on the recording. You've just had your jump start. Where do you go next? And I was overwhelmed. It was a while ago, but it was daunting. From there, you'll probably grow out to multiple servers. And what we hope you take away today is something that might help you improve your architecture, or just something to take away to maybe look at the security of your environment. After that, you might be able to split out your infrastructure to make it more fault-tolerant or more scalable, depending on the needs of your business or your organization. The next step's probably going to be a presence in the DMZ, when you start to really work on making a good service available for your users and fleshing out some of those other Apple services, making dep available offsite. Using load balancers, they're helpful for us from both a scalability, a fault tolerance perspective, and there's some security benefits from doing that as well. And finally, maybe you're with a large organization or you have a very disparate user base across the globe. When you start spending more time on your infrastructure than you do on your service, it's time to consider some of the cloud options, or possibly a hybrid where you have an on-prem and a cloud infrastructure base. So this is where we all started out. We've got that one big host. It's running MySQL, Tomcat, and it's our distribution point. If you're a small shop, maybe that still makes sense for you. Your prime responsibility at that point is making sure you've got good backups, both for data recovery and if there's hardware failure. But most of us probably want to grow beyond this point. At that point, one of the easiest ways to grow is to add an extra distribution point. This one's an easy win, and it makes sense. You probably have more than one location. Adding in this extra distribution point is going to ease the experience for those people that don't have the latency downloading all of the files from one location. It starts to get more interesting when we're able to split out the infrastructure. It also makes us a little bit more fault tolerant. When something does go wrong, you're not scrambling to bring up every single piece again. You only have to replace the part that has the issue. We hope that that doesn't happen, but it does. That's why we all have jobs in this industry. In this particular example, we split out the database, and we also have a separate Tomcat node, and we have our two distribution points. At the moment, we're still fully inside our corporate network, so we have very limited services that are available outside. Where it starts to get interesting is when we have our presence in the DMZ. The red line is sort of indicative of internal versus external, but in reality, you're probably going to have another red line towards the left of that Tomcat and that MySQL instance, and maybe additional infrastructure as well. Once we have that presence in the DMZ, we're able to provide much more services to our users. We can remediate assets that are off-site or off VPN. We can have remote enrollments, and we can deploy packages wherever or not they're on the network. With this particular infrastructure, with the split distribution points, there's a few things that come to mind. If you have restricted content, you do have the ability to make some content available internally only and some in the DMZ. There's some extra effort with syncing your distribution points, and there's also some extra overhead here because we've introduced an MySQL slave. We strongly recommend always having a slave so that if something does happen to your database, your time to recover is quicker. Once we get past that point, it's really time to think about using load balancers. In this particular example, we've made use of global load balancing. We all know that there's a lot of overhead with scoping out distribution points to clients, making sure the clients are hitting the correct distribution point. We get that wrong. Instead of making the experience better, we've actually made it worse. By taking advantage of global load balancing capabilities, the load balancers are taking away that overhead. They're determining which distribution point to hit. And you can have a user that might be sitting in Europe, make sure that they're hitting that European distribution point instead of traveling back to New York, and also provide a similar service for those in Asia, or wherever your user bases happen to be. By clustering the distribution points in your data centers, you're able to have a fault-tolerant and scalable architecture. This means that when it comes time to do that monthly patching, you now have the ability to do that with minimal interruption, if any at all. We've also started to cluster the Tomcat instances. One of the important considerations at this point is latency. You need to have your Tomcat instances close to your database. The further they are apart, that's going to start to get interesting. But by load balancing them, you can do your monthly patching of your Tomcat front ends without an interruption to your service unless it comes time to upgrade your Jamf version. By having a separate node on the inside, we've separated the administration and the client-facing functionality. This allows you to do the administration internally without exposing that interface on the internet. And I have to reiterate, we never recommend putting hosts directly on the internet. We always recommend having another layer there. For the purposes of keeping these diagrams simple, we haven't put that in these slides. You also have the flexibility at this point. Maybe you don't want to make the API available externally. By having an infrastructure layout like this, you can limit the API to perhaps only be available on those internal nodes. As your business grows further, and you start spending more time on the infrastructure than you do on the service, it's taking up all your time, and you're not putting your energies into the environment and making the Mac experience as good as it can be. That's when it's time to look at whatever options there are. If I'm spending all my time patching distribution points and trying to keep them in sync, I'm not putting my efforts into making the service good or offering new features to the user base. Some of the options that are available are Akamai, S3, and Rackspace. There's also Jamf Cloud, which is a really great offering if you don't want to have to think about the infrastructure at all, and then you get all the benefits of Jamf's experience with maintaining the Jamf Cloud service. I'm going to talk a little bit about Akamai as a distribution point because that's the one I'm most familiar with. With Akamai, you no longer have to think about syncing your distribution points. You upload to Akamai, and you're able to leverage their global distribution network. But by using that, there's a few important security considerations. One is to make sure that you work with your Akamai representative to enable HTTPS and token-based authentication. You want to make sure that you've got your checksums enabled as well to verify the packages. Also, in this example, we still have load balancers for Tomcat. We've added an additional load balancer to the inside. As your business grows, you might find that there are multiple teams using the administration interface or making API queries, perhaps for HIPS checks, asset management, or other tasks. By having an additional load balancer here, again, you can patch Tomcat with limited or no interruption unless you're performing your Jamf upgrades. I'm going to pass across over to Brandon and then Chris. They're going to speak on some of the security concerns with Jamf. And again, we're really appreciative they're able to come here today.
How's everybody doing today? All right, cool. Like Lisa just pointed out, my name is Brandon Coates. I am on the Paranoids team at Oath. Paranoids is a security team. More specifically, I am on the vulnerability management team. Let's make sure I don't go too far. And so I am a security professional, and I go to a lot of security conferences. And so the reason you see memes on my slides is because that's one of the 3 things you have to have at every security conference. You have to have memes, so that's why I had the cat. You have to have a guy in the hoodie. That's what that is right there. Hacker Man for Mr. Robot. And the 3rd thing is cussing, but I'm going to try not to do that, but we'll see how this goes today. So kind of going back to Lisa's point about load balancers. She covered a lot of the resiliency things that I was going to talk about, and that's great, because that's one good thing you need to know about load balancer. It does give you a lot of resiliency. The reason I want to talk about the resiliency is because you need to patch your stuff. You're going to hear me say that repeatedly. You need to patch everything, and when you patch it, check it and patch it again. So a load balancer gives you the ability to say, okay, you have 3 servers in the back end. You know, if excuse me, let's do a simpler example. If you have 1 server, you patch it, it has to reboot, you're down for that time it's rebooting, if it comes back up, because I've been there too. But if you have load balancers where you have 2, you can patch 1 at a time. You can test out the patch. Your load balancer is going to direct all traffic to the one that's still running like normal. But if for whatever reason, it can, that's what it's doing. It's diverting your traffic. So you don't have to worry about that. Your service is still up. Also, it gives you a good choke point. From a security professional, that's good because it gives me the ability to hook in there and do logging. So let's say there's an incident that happens, but all your traffic is going through one load balancer. That way it's easy for me to inspect all the traffic because the traffic's going through one point, you see going in one point, you see coming out one point. So it gives you a very good place for you to check all the traffic going in and out of your network. Also, it gives you cloud options, and one thing I like saying now, because it used to be, if you need to do load balancer, you need to buy another appliance, you need to do a lot of calculations about how much power am I using, blah, blah, blah. Not no more. With cloud options, it's pretty easy. We're a big AWS shop, so we are very familiar with what are called ELBs, or Elastic Load Balancers, within AWS. And a lot of that logging I was talking about is already included inside the ELB, so it does a lot of that for you. And then lastly, as Lisa was pointing out, it gives you a lot of location selection. So that way, let's say we have different regulatory concerns. So you have users in Europe have different concerns than users in America. By using load balancers, you can divert that traffic to the right place, so that way you're not mixing things along the way. And then the one thing we're going to talk about today a lot is encrypting things. And this is kind of the basis of encryption, at least when it comes to transfer encryption when things are going on the internet. So certificates are one thing we're talking about. How many of you have used a website with HTTPS, you got that big red X from Google? Well, that's because people are using certificates incorrectly. So they're using what are called self-signed certs, or maybe their certificate is out of date. And the way certificates work is there are big certificate authorities. You have like Entrust, Symantec has them. And what happens with those is they say they know who Brandon is. The certificate authority knows who Brandon is. Your browser trusts the certificate authority. Therefore, you trust me when I say I'm Brandon.com. So you come to my website, you ask the certificate authority, is that the right one? It says, yes, it is. Then you say, all right, cool, I'm on the right website. When you get that big red X, certificate authority is saying something's not right here. You can still go to the website, but be warned something's going on. So that is basically how certificates work, is certificate authorities on the internet. And those are the basis of TLS or SSL, which I'll let Chris talk about later. And he's going to get a little ranty about that too. The problem with TLS is it used to be pretty expensive. Like I said, you had the companies like DigiCert and Symantec, and those certs are pretty expensive. They're coming down in price, but they're still pretty expensive. However, now the EFF has started this thing called Let's Encrypt. So with this, you are now able to secure your sites with TLS pretty easily. It's a free certificate. The downside is it's only good for 90 days. So every 90 days, you have to renew that cert. You say, oh man, I forget how to do that, blah, blah, blah. Well, they have this little thing right here called CertBot. CertBot is something you can install on your machine, and it'll update your certificates for you every 90 days. So that way, you can ensure your sites are encrypted and they're TLS ready. Let's see, yeah. So that's all I have for certificates right now. Excuse me?
They do extended validation?
Yeah, the certificate authorities would do the validation because they run their own certificate authority.
Not currently. They're looking into providing that later next year, along with wildcard certs.
Yeah, which is one of the reasons why some people still use the paid ones. Wildcard certs basically means you'd have to get a certificate for every one of your domain names. Wildcard would just be like star.u.com versus you could do that with a paid service. You can't do that with Let's Encrypt now. You have to do to blog.me.com and then site.me.com. So like I said, we don't want any data passing in the clear ever. This is one of the big things, even on the back end. Now, I know I kind of just bashed self-signed certs on the front end, but that's internet facing. If you're on the back end where your servers communicating with each other, you still want to encrypt that traffic because security people, we're paranoid. That's why we call that sometimes. But we just assume that the bad guys are already in your network. So if they're in your network, it's very easy for them to set up a sniffer and just listen to traffic going across. If it's in the open, they can pull out passwords very easily. You can pull out all types of things and map the network. But if it's encrypted, it's a little harder for them to do that. They can still do it, but it takes a lot more effort. And most times, if you're being attacked, they're going for the quick wins. They're not going for the long haul. Unless you're being attacked by a foreign nation state. In that case, game over. And one place you definitely want to don't forget to credit is the database. And Lisa has a little extra on that.
Yeah, that's a really good point. Thank you, Brandon. You might notice in your Jamf instance that by default, the database is probably not encrypted going to and from the Tomcat web apps. There's some really good information up on Jamf Nation. It's an easy change to the database.xml. And if there's one thing we can all take away today, go home, make sure everything is encrypted, all that data at transit. And one point I forgot to make during my section, and sorry, Jesse Dunn, I see you there, I'm going to embarrass you. He did a session a couple of days ago. As you scale your infrastructure, you also need to tune your infrastructure. Jesse and his team have some awesome resources how to tune that to make sure that adding an extra host is not going to cause you a problem.
Yeah.
Brandon, go ahead.
No problem. So once again, back to your distribution point. So you're handing your packages out to the users. And the one thing you gotta understand is that your users are trusting that you're giving the right information. So it's very easy. That's another thing that hackers could do. I had to talk Chris out of doing this before he came to this conference is, it's very easy to pick packets out the air, change them, and send them on the wire, and your user wouldn't know the difference. So that is one thing that at least in the mentions, the checksums kind of stops that. HTTPS stops that, because another concept of security is you want to have security in depth. So we have multiple layers of security there. So first thing you want to do is enable your checksum, so that way when it gets to the user's computer, they're making sure this is the package I want. And then if you use an HTTPS, it's harder for Chris to jump in the middle and change that package. And the reason I say that is, it's very easy for me to go in there and change a package a little bit, and now I have you executing something, and it could be executing as root. So I can make you do whatever I want at that point, and it's game over. So you always want to make sure you have your TLS enabled on your distribution points. And also, you want to use TLS with modern ciphers. The reason we bring this up is because TLS uses a whole bunch of different ciphers, are available to it. According to the protocol, you can use a whole bunch of them, but a few of them have been proven to be broken over time. So they have what are called modern ciphers. So if you use Mozilla has a very good tool. If you go there and let's say you want to just do an Nginx server, you can go on that website, you can say, I have an Nginx server and I want modern ciphers. It can spit out a config for you. You can kind of look through it and learn how you can make your web servers more secure as well. So another thing I want to talk to is, especially since we have a lot of sysadmins in the room, is some steps you guys can take to help secure yourselves and your network as well. So the first thing is regular patching. Patch, patch, patch. 90% of the time, it works every time. So you got to make sure you patch everything because that takes away a lot of your security vulnerabilities themselves. Everybody's familiar with the whole Equifax thing right now. So everybody's saying, if they just would have patched struts 2, that would have stopped it. I'd argue maybe because, like I said, everything happens in layers. So that struts 2 might be the entry point, but there can be other things for pivoting around inside the network. But patching probably would have said, made the hacker go, all right, that's not going to work. Let me look for something else. So make sure you patch your stuff, patch it, patch it. Also, you don't want to share your credentials. I know it's very easy because I used to work in a small shop with me and one other guy, and we had, this back in the days, Windows. I'm sorry, it was Windows. I was government world. That's what we did. But it was a Windows environment, and sometimes you want to just make an easy password or something you guys can share so that way you can go in there and do things, he can go in there and do things, but you don't want to do that because credential sharing gives you all types of issues. The first thing it gives you is you have a password. Let's say you're very good with your password. You know what it is. You don't write it down. What's to stop them from writing it down? Put it on their laptop, going out somewhere, the Post-it falls off. Now someone walks around, it has the password to your system now. So you don't want to do that. Also, it gives you the ability for logging again. And logging is good for blame game. So if something does happen, you can say, I didn't make that change. Let's go into logs and look at who's logged in and did that. If you have one username, there's no way to say, I didn't do that. Both of you are in trouble. So at least that way, you're doing a CYA by doing it that way. I almost cussed there. I used an acronym, though. It's good. And another thing is user admin account separation. So once again, this is from when I was back as sysadmin. This is something bad I used to do back in the day. I gave my user account all the admin privileges because you know what? Why would I log out? Why would I do that? No. You need 2 separate accounts. You need a regular user account like everyone else has, so that way when they have issues, you can replicate their issues. But also, in case that account ever gets popped, you want your admin account to be more secure, and I'll talk about that in a second, about how to secure these things. But you also want to make sure your admin account is more secure. So that way, if the user account ever gets popped, they also don't have rights to your admin stuff as well. And then the last thing we'll talk about is 2-factor authentication. So that's when I say, if you log in with an admin account, you want to be sure you enable 2-factor authentication wherever you can. I believe Jamf does have that available in the console.
Yes.
And so if it is available, use it. A couple caveats on that. Something is better than nothing, so SMS would be something, but I'll highly recommend using an app such as Duo or Google Authenticator or Authy. The reason I say that is because actually the Duo guys brought this up earlier too. The Duo guys did a talk earlier about the Kool-Aid man, but they say, if someone steals your laptop and you were signing with iMessage and they open up your laptop, let's say they're able to get into it somehow. And now that you have some of your passwords, since they have their iMessage, they can actually get your 2-factor authentication, so you kind of defeat that. And actually, I think there's been a lot of proof of concepts out recently in the security world about people spoofing phone numbers in order to get in there. I think some people think that's how a lot of people, celebrity Twitter accounts have been getting hacked lately. So they had it turned on, but they had SMS, and so you could just spoof a phone number pretty easily and get that message. So, and then one last thing we'll talk about is password managers. Here's an example of a few of them. LastPass and KeePass are open source ones. They all do the same thing, and basically they give you the ability to save long, strong passwords. You can save them in there, so you can go to websites. I use 1Password a lot. I just hit Command/ and boom, the password's in there. I have no idea what most of my passwords are, to be totally honest with you. I only have to know 1Password to get into the actual system. And they also, I know 1Password and LastPass also have the ability to store a 2FA token inside them as well. So those are some things I definitely would recommend that you do as a sysadmin. And then one last thing I'm talking about before I get out the way is definitely vulnerability scanning. So like I said, I am on the paranoids team as the big thing. Oops, went too far. Oh no, one more. There we go. So I'm on the vulnerability team as the paranoids team is the big security team that goes across all Oath worldwide. But more locally, I am on the vulnerability management team. And so it's our job to do this. So basically what we do is we look for all the issues. We look for all possible vulnerabilities in our system. And here's some of the big tools that we use. We use Nessus and Qualys. So those are paid tools, but they also have free versions. And then you have OpenVOS, which is an open source tool that you can use as well. And the reason I would say you should use these, even if you have a small environment, it doesn't matter. If you have a small environment or a big environment, you have holes, these can help find some of them and help you fix a lot of your problems. Also, it can help you make sure your Jamf patches are being pushed out appropriately. So let's say a new Flash vulnerability comes out, because those never happen. And you tell everybody to update their Flash. You can make sure by using a vulnerability scan to say, is everybody on the right version? It'll show up in those reports from all these tools. But the one problem we have with vulnerability scanning is you have to know what you're scanning. What I would say that is, you can have a big IP space, you need to know what's there. So there's other things you could do. And one thing we use a lot is Nmap. So you have to know where things are in order to scan them. So those are the things I definitely want to say you should do. If anything you take nothing away from me today is encrypt all your stuff, scan everything, and patch again.
Thanks. So I'm Chris Holt. I'm a security engineer at Oath. I've worked with Lisa in the past on doing some of that vulnerability scanning and getting our Jamf systems patched at Oath, and to great success. But I wanted to talk about the hackability of the system. So it's time to face the music here. Brandon talked about a few things you can do to protect your system, and I'm going to talk about how specifically weak it is. Urging you to go back, watch that part again, go do some more research, read white papers, watch more security talks. But I want to trigger something in you to follow up on this stuff. So first off is the man-in-the-middle attack. Man-in-the-middle is game over. It's the end. For admins, probably. For users, absolutely. Patching is easy, but there's definitely some numbers I can show you that should scare you. And if you're not patching, hopefully you will after you see some of these numbers. And then more about TLS. That's a personal cause of mine. So I'm going to introduce you to that. So if you recall this diagram from earlier when Lisa was talking about scaling, right? This is our middle of the road progression, where we have a few servers in the DMZ, right, outside of the corporate network, right? So that red bar in this case is our firewall. This is our main protection for the network, and we have a few systems outside it. When we have systems outside, they are inherently exposed in some fashion. In this case, we have our Tomcat and our distribution point outside of the network. Right? That helps us get the distribution out. That helps accessibility of all those patches, all those policies that you're pushing out. But in order for that to work, you want to protect your MySQL. So you have that inside of your network. In order to connect, you need to punch a hole in your firewall. A hole is a hole. Good things go through holes, bad things go through holes. A hole is a hole. So you need to have extra protections there for whatever goes through there, whatever connects. Right? This is where we can have mutual TLS authentication. We can have IP tables to control routing, what packets can actually go through from one side to the other. But let's say someone gets access to one of those DMZ servers. Oops. Let's say it's the Tomcat server, right? Tomcat directly is able to talk to the MySQL. So now, just because I have control of one of these servers, I can directly now talk to the other side of that firewall that I'm not supposed to be able to get through, because that's what you set up. This is the design that you built, and if I'm able to breach one of these points, I can get through to the others. On that Tomcat server, we can change policies. I could lock out admins. I could change packages that are going to be distributed. Pull down data from the database. Change the database, right? Delete the schema. If you have access to the database, maybe from the Tomcat server, maybe from coming through that hole in the firewall, right? You have information on every single asset that's tracked from the system. What could you do with information about every asset that's being tracked? A lot, right? It's a similar kind of thing that we saw with Equifax, where they patched a lot of things and they missed one. They didn't think it was a big deal, and they got hit, and that became a jumping point into their system where they lost all of their data, just like your asset information. If we control the distribution point, maybe not the Tomcat server, but the distribution point, right? I could upload a malicious package. I could add malware into an existing package that automatically is now going to get distributed on the next policy check, right?
Just one moment, there are a couple of ways to help mitigate that type of attack, and we always recommend that you use the checksum feature. Sorry, Chris.
Yeah, absolutely, right? But once again, even if you control the system, right, I would be able to recalculate the checksum and change that, put that maybe back in the database where that package is being checked. So you always need to make sure that you are patching and up to date, because vulnerabilities exist. A single vulnerability in an open source library can cause massive amounts of damage. Tomcat is your web server, right? We've seen that. OpenSSL is the library that's used for encrypting information in transit between your client and your server and your database, your distribution point, and the clients. It's used everywhere. MySQL, again, is your database. These are all open source packages. Open source has some great benefits to it, but one of those benefits is a huge danger. Because it's open source, attackers can go look at the code, inspect it, do rigorous testing on it. In the left column here, we have 10 years worth of vulnerabilities. Right? These are CVE counts from the Common Vulnerability Database, which has been tracking vulnerabilities that have been published since the early 90s. So these three packages have been around collectively since '99. So we have 10 years in the first column. The second column, which has similar numbers, we only have 5 years of vulnerabilities counted. And in that third column, 3.5 years. So across there, we see similar numbers, but the timing is shortened. Does that not worry you that there are increasingly more vulnerabilities researched, published every year? With every vulnerability, there is likely a patch. Sometimes a few get rolled into one if they get published together. And with those patches, we see an opportunity for you to upgrade your software. So let's say you're doing a great job of patching and updating, and every full moon you patch because the crazy people come out with the full moon, and you want to avoid that nonsense. So you patch the day before. Well, that's about once a month, right? Well, so far in 2017, Tomcat has seen 8 major vulnerabilities published. And these are numbers that I pulled in October. Sorry, not October. End of August, right? So that's about once a month. Okay, so if you're patching once a month, you're no more than 1 month behind. With a major vulnerability, you may be okay. What about OpenSSL? OpenSSL actually had 22 vulnerabilities against various versions, against different ciphers, 22 vulnerabilities. So if you're patching once a month, and we've got 22 vulnerabilities in the first 8 months, what are the odds that you're actually up to date? It's almost none, right? You need to be patching, in that case, every week in order to catch up. So this is a concern. And OpenSSL particularly is your TLS library. Even though it says SSL, it's your TLS library. This is my personal cause. TLS is not SSL. Don't mix them up. They're not the same. It's like toast and bread. Kind of the same, but not. Toast is bread, but bread is not toast, right? Secure Socket Layer was originally a protocol that was, not protocol, it was a library that was built by Netscape to protect their communicator and navigator software back in the early 90s. What was it, 94 was when they originally built it, and released it in 95 with the software. So here's our timeline. Right? TLS was what the IETF, the International Electronic Technology Frontier, I don't know what they're called. It doesn't matter. That's the group that has all of the information about protocols on the internet. But they took over SSL when Netscape said, this is way too important. We can't hold on to this stuff, so we need to publish this because transport security is important and more companies need to be doing this. Everyone else should be worried about it, and nobody was at the time. So they took their software, open sourced it, and TLS 1.0 was born as SSL 3.1. We don't see that on here because it really changed. There was small, minor changes in the protocol, but a major version change because it was open sourced. That was 17 some odd years ago, 18 years ago now. That's a long time. Does anybody have a piece of technology that's 18 years old that you trust? No, right?
AOL Instant Messenger.
Not anymore. We turned that off last week.
Yeah.
Right? But even so, that's been updated since then. It's not 18 years old, right? So, okay, well, let's say we've updated TLS a few times. We have 1.1 and 1.2. 1.2 is still 6, 7 years old by now? Do you have anything that's 7 years old that's technology that you put your personal, private, secure data on that you trust to not be published and attacked easily? No, there's vulnerabilities in that. So as a protocol, 1.2 has vulnerabilities in it. Every single one of these red bars, which I'm sure you've all been asking yourself, what could those possibly be other than happy check marks, right? Those are major vulnerabilities in the protocol, attacks on libraries, bad code that was submitted, shady behavior from the certificate authorities and other groups that run the backbone of SSL and TLS on the internet. These are huge problems with this entire ecosystem. So it's time for an update, right? 1.3 has been in draft for a few years, and it should be adopted pretty soon. But the IETF has made sure that they're taking their time getting this right because it's super important. And we see that time and time again with all sorts of, every one of these attacks, right? We see that this is more and more important to get right. So if you had trouble seeing that, I know that was kind of a rough diagram. You could check out more information on that. Every single one of those red bars, I pulled up a white paper or a presentation or some other, like all the research behind that. You can check that out on the link at the bottom there. But each one of these is more information on what you can do to protect your Jamf system. And you should, starting with regular patching, more than once a month, because that's not enough. If that's the one thing you take away from here, once a month is not enough.
We've got a few takeaways now. Maybe you can all pick one or two.
Yeah. Right? But keep learning. Go study more. We want you to take something from this that you should go take more. Right? Brandon?
And once again, we're going to beat you over the head because we love, so there's been a meme going around, and this happened after I submitted this, you know, where it shows two people talking casually, like that's how I feel like I'm talking about InfoSec, but I actually look like Charlie from It's Always Sunny in Philadelphia with a big board and all this stuff going around, like, look at all this stuff. So here's some good things you can take away too for good hygiene for yourselves. It's monitor patches. Not, I put Tomcat up here, but you can do more in Tomcat. As Chris just pointed out, MySQL and OpenSSL. And like you said, we're seeing a lot more vulnerabilities, which actually I think is actually a good thing. That means we have more eyes on the code now. Because it used to be maybe just the bad guys looking at that code, but now you have more developers looking at that code and making commits to that code and trying to improve that code. So you definitely want to do that. So that's the website for the Tomcat. Usually every website has a different one. So that's one way you can kind of get all your, you need to figure out what you have. So one of the big things, you need the software inventory. When you have that software inventory, you can go out there and, you know, kind of get all your websites information. You can say, hey, I need to look at this site, this site, this site. One way I kind of help myself do that is by using RSS feeds, once I know those, especially if the sites have an RSS feed. So you get that stuff rocket fast. You can get you could use the Slack command. This is how I do it. And I use that link. And so that way, every time OpenSSL comes out with a new patch, I know it. And if MySQL comes out with a new one, I know it. We have other feeds. And also the NVD, the National Vulnerability Database, they actually have RSS feed. And that spits out a lot of information. But that's one way you can always stay up to date. And once again, you want to rotate those credentials. You want to make sure you're getting everything going around there. That's all I have for that. You have any extra?
And we got one takeaway. Yeah. Go home, check to make sure everything is not passing in clear. No data shall pass in clear ever.
And that is it. Questions?
Awesome. We can.
Awesome.
Oh, Jesse.
You work at Jamf, no questions. I'm just kidding. I'm just kidding, Jesse.
Longtime fan, first-time caller. I was wondering, how does the security team feel about hosting an application like the JSS in the cloud? Are there security concerns that you guys had to address, discuss internally before that was a move you guys made, or do you feel very strongly that the data is secure enough to be held in the cloud?
So that's one battle we've been having a lot lately about stuff going to SaaS products in someone else's cloud. One way, we have a couple ways doing that. So we're both part of our risk organization as well. We do give these questionnaires where we ask basically the provider. So it could be either someone as big as AWS, or it could be a small someone that like Jamf, if we're using Jamf inside AWS. We would give them security questionnaires, and based on what they come back with, that's where our decision usually comes down to. But people have been getting more comfortable by giving our data other places, but it's not to mean you can't get burnt by that. There was a big write-up recently about our parent company, Verizon, and they had personal data out there on the internet because of S3 buckets. But that wasn't actually Verizon's fault. It was a third-party vendor who had it. It just had Verizon data. So it's still a risk, and people just have to accept that risk, but you can mitigate it by asking those questions and saying, how are you guys encrypting data? How do we get data to you? How do people get out of it? Who has access to that data within your company? So those are ways you can kind of look at that risk and make your decision if you want to take that risk or not.
Perfect. Thank you very much.
We will make this deck available later, so if there was something you missed, you can go back and take another look. All right, great. We're done. It's a wrap.
All right, thanks, guys, for coming.